Hi friends, welcome to second lecture of Start Pro. Let us open the Start Pro, create new project. Today we'll plan for 3D. So we are selecting new space, file name as 3D structure. Length will take as millimeters, force will take as newtons. Next, add beam mode, finish. In the 3D frame, it will directly appear the grid mode. We will close the grid mode and run the structure analysis in the geometry. As you can see the geometry in the top of the screen, that is geometry. In the geometry you select run structural wizard. After selecting the run structural wizard, it will open a new screen, default structural wizard. In this we have to select a prototype models. In the prototype models we will select frame modes. Now in the 2D frames we will select bay frames. We have to double click on the bay frames. Let us assume some dimensions for the 2D frame. Let us design for one floor of 3D design, that is ground floor. Let us first design for ground floor. In the length will give us 10 meters. In the height, a single story that is equals to 3 meters height will take as width as again 8 meters. In the length, number of bays, let us take a 3 bays. Let us take a 3 bays with the different components, that is one is 4 and the second and third component is 3 3. And select OK. In the number of bays at height is single story, so we are selecting only one. Number of bays of height is equals to 1. In the width wise we'll select again 4 bays, it will equals to 2 meters. Apply. Now you can see the frame in 3D. It is 4 meter distance, it is 3 meter distance, it is 3 meter distance, and here 2 meters, 2 meters, 2 meters, 2 meters. Along lengthwise 3 bays, along widthwise 4 bays, height is 1 bay. Now our drawing is completed. Let us transfer to the structure. So we'll click on transfer mode. It is in the top of this item view or menu ribbon. It's look like a paste symbol. Click on paste symbol. It will ask the command, just click on yes. Here you can change the reference point wherever you want. It is our first reference point, so I am selecting all the directions as 0 mm. It's clicking OK. Now my structure is ready with 3 meters height, 10 meters length, 8 meters width. I am closing my grid view. Now it will look. You can cross verify your dimensions by clicking on dimensions view on the dimension floor. whether you have taken right or wrong. You can remove dimensions by clicking on remove. Now geometry part is completed. We have to give property of the structure. So we have to select on general as we have done previously in the 2D frame structure in the first class. Let us define two types of properties, one for column, one for beam. Here you can observe that it is x direction is this, along lengthwise is x direction, along widthwise is z direction, along height is equals to y direction. You can take your origin, just click on show origin, it will appear. Here you can see that along length direction is x direction, along height direction is y direction. For getting the origin, you have to right click your mouse, select labels, click on show axis at origin, it will appear. Or you have to remove, you can just deselect the show axis at origin, it will be deselect. Like you can observe here, I am selecting the origin to understand you better. Now our origin also ready. Wherever the origin starts, that is the initial beam, you can say that. Now let us define few properties. Let us take rectangular sections. In the property definitions, let us give 250 mm as wide and 350 mm as depth for one section, and another section let us give 250 mm as a square beam. Let us give the property for beams 0.25 meters, 0.25 meters, and for column 0.25 into 0.35. At first we'll assign the columns. For selecting the columns, you have to select the reference point 1, that is rectangular section 0.25 into 0.25. For assign the property, as you know, you have to go to select beams which are parallel to y direction. As you can see in the origin, the y direction is upwards. All the y direction beams are selected. Just you have to click on assign to selected beams and assign. Automatically all the perpendicular beams are assigned. You can see here R1 is showing. If you have any doubt, you can see in the 3D view which it will be appear clearly. If you want to change your orientation of the beam, you can also use the beta angles. How to change a beta angle? This beam, and this beam. For the three beams, I want to change the orientation. 1 2 3 1 2 3, total 6 beams. I am changing my orientation. In the middle of the story, I am changing my orientation. For to create an orientation, you have to beta angles, go to beta angles, create a beta angle. Our orientation angle is 90 degrees. We are changing from parallel to perpendicular, so we'll select 90 degrees angle. It will create beta equals to 90 degree. To assign the beta is equals to 90 degree, you have to you can use directly, or you can select the beams first select on beta 90 degrees and then select the beams which you want to change your orientation by pressing the control button on keyboard. After selecting all the beams which you want to change your orientation, just click on assign. You will ask the command that you want to assign it or not. Is it everything is you are doing is correct? Just do on assign. Yes, it will appear the name also, beta is equals to 90 degrees. In the previous you have seen that all the columns are in perpendicular direction. Here few columns are in perpendicular directions and few columns are in parallel direction. Just you can see in 3D view clearly that in the previous all the beams are like in this manner of the orientation. Now the orientation is changed. You can clearly see that the orientation is not in the it is perpendicular to this beam. This beam is perpendicular to this beam in the second point. Here you can see in the top view the beams which are beta angles are the depth is less, width is more. In the top view you can see the beam orientation also. Closing the 3D view, and applying the second property for beams. Now the column property is completed. Now we'll give to beams. To select the beams, you can directly select beams which are parallel to X. Select again beams which are parallel to Z. Here you can see that the direction of the beams are in the direction of X and Z. It is in the direction of lengthwise and it is in the direction of widthwise. All the beams in the direction of X is selected, all the beams in the direction of width is selected. Directly you can assign, yes, all the beam, all the total ground floor structure, all the properties have assigned. If you want to cross verify, you can see in the 3D view all the beams have get their properties. At first you can see just a dot, a line in the top view, but now the beam orientation is came and the property is assigned, so it is in somewhat depth, somewhat width in the orientation. Close the 3D view. Up to the property, you have any query, you can make it on the comment. I can clarify you in the next class, or I can mention your name and can send you personally the orientation video. And now we'll go to the next step. We have done only 2 steps. At the first step we have drawn the geometry, and the second step just we have assigned the properties of the beam and column. Now we are moving to third step. To move the third step, let us select the front view, that is plus Z direction, and from the front view let us create a support that is fixed. Select the support and select the front node, front all nodes. Either you have selected wrong, you can see in isometric view to cross verify either any cross check the orientation selecting of nodes. Just click on assign, all the bottom nodes will be fixed. It will not appear in 3D view, the beams are fixed, but it will not show any change in the 3D view. And the third step is completed. In the fourth step, let us move to the load and definition. In the load and definition, there are several definitions for individual term. For example, here 8 terminologies are there. I will read one by one. Vehicle definition, time history definition, wind definition, snow definition, reference load definition, seismic definition, pushover definition, direct analysis definition. In the vehicle definition, you for every definition you have to refer their respective codes. At present I am not dealing with definitions. Let us create few loads. To create few loads, let us think that for a story building, for a single story building, what are the loads will be act on the building. The self weight will be act on the building, and the live load will be act on the building. That is dead load and live load. The two major loads are added on the building. If the building is constructed in the seismic zone, you have to add the definitions of the seismic. If the building is constructed on the wind region, you have to add the wind definitions also, but at present I'm doing the 3D structure with only dead load and live load. So let us create two types of load, dead load and live load. To create two types of load, let's first select on load case details, click on add, select primary, number 1, that is dead load, give title as dead load, add. In the primary, number 2 is live load, click on load type is live, title as live load, add, close. As explained before, I have assuming only two loads are falling on the structure, that is dead load and live load. At present, let us create few dead loads. Majorly the dead load is nothing but the self weight of the building, but you have to think that the only self weight is acting on the building. There will be act some furnitures, some materials, cupboards, etc. We have to give the dead loads also. For example, that is you can assume that is as a floor load also. So I am creating two loads in the dead load, that is I am adding two types of dead load, that is self weight in the -1 factor, that is total to be applicable, and a member load, that is -5 kilonewtons. I am assuming that the total building will be -5 kilonewton is permanent dead load, that is -5 kilonewton 5 newton per mm is permanent dead load in the global axis of y direction, that is -y direction, to act the gravitational force downwards. I am selecting -5 newtons per mm, that is adding and close. Here you can see that the question mark, there is not assigned that load, so I am assigning self weight as the entire view. By assigning, you can highlight all the beams and columns that the body has assigned the load. So I am assigning the -5 newton per mm load for the entire story, only beams, that is beams are parallel to x and beams are parallel to z. The load is applicable only on top, not for columns. From beams the load will be transferred to columns. So assign to selected beams, assign. The dead load is assigned. You can check your dead load is correct or wrong by clicking on labels, load values. It will show -5 newton kilonewton per meter or 5 newton per mm. I am saying in mm, it's showing in kilonewton per meter. Both are equal. I am disabling the load values. Now I am moving to live load. For live load, I am assuming that the story will be have half of the dead load, that is -2.5 newton per mm or kilonewton per meter is the live load, which is temporary acting on the building. That will be assigned both the direction of x and z. Assign to selected beams, assign. Yeah, the both dead load and live load has assigned to the building or assigned to the structure. Now let us create a combination of load. Why it is important to create a combination of load? It is important because it is not that the only dead load and live load will be act on the building. There will be acting more loads on building, so we have to create the factor of 1.5 of dead load plus live load. So I am making a combination load by selecting on load case details and clicking add. In the third one is load defined combination. I am creating 1.5. The 1 is the default. I am selecting 1.5 as a factor and selecting the two loads, dead load and live load, that equals to add and create. Here creating the combination is equals to the assigning the load. The load will be automatically assigned. In this structure we have created the geometry, assigned the properties, fixed the geometry and add the loads. Now we have to perform analysis, so we'll click on analysis and print. We'll click on add. It will show here perform analysis, so it closing the analysis print command and analysis this structure by clicking Ctrl plus F5. Let us wait for 1 minute. The analysis will be performed. You can see here 0 errors, 0 warnings, 0 notes. So we have done perfectly correct. Let us design the column and design the beam first for a one-story building. To design, select design and in the modeling select concrete. As we know that we will follow the IS 456 limit state method, so we'll select few parameters which we well known. So current code is our IS 456 2000. Select parameter first, deselect all the parameters, select compressive strength of concrete, that is FC, yield strength for main reinforcement, that is FI main. OK, close, and define the parameters. FC, let us give M20, that is 20 Newton per mm square. M20 grade concrete for the entire structure will assign, and FY main as 415 Newton per mm square or megapascals for the entire structure. We have to give few commands, that is column design, design beam command, design column command and takeoff. The takeoff show the result of reinforcement and concrete. We have to assign that property, yet the properties are not assigned. As I said before, FC20, that is M20 concrete for our entire structure, so we'll assign to view. Yes, FI main FI 415 main reinforcement will assign to entire view. Design beam will be assigned for along the x-axis and z directions.